Welcome to EPG Pathshala. Today we will be discussing about mountain building, theories related to mountain building and plate tectonics in detail. Now let us look at the learning objectives. We will be discussing about the concepts and theories of mountain building process. We will be explaining the theory of continental drift and elaborating the basic principles of plate tectonics. We will also describe lithospheric plate, plate boundary and plate margin. We will also recognize the causes of plate motion and convection current theory. Lastly, we will be discussing about evolution of Himalaya as the present day example of plate tectonics. Concept of mountain building. The process of mountain building is known as orogenesis. Earth has many times witnessed process of mountain building. In Earth's history, three major orogenic periods have been recorded. First is Precambrian orogeny, that is before 550 million years ago. Second is Hercynian orogeny, that is about 350 million years ago. Tertiary or Alpine or Himalayan orogeny to present day. Theories of mountain building. Several theories have been put forth for mountain building: contraction hypothesis, expansion hypothesis, oscillation and undation theory, convection current hypothesis, continental drift, theory of plate tectonics. Now, let us summarize the contraction hypothesis. It is based on the thermal history of the earth. Inner portion of the mantle, that is below 700 kilometers, was neither cooling nor changing in volume, and the outermost layer about 100 kilometers has already cooled and is not changing in volume. Therefore, cooling and contraction resulted in compression in the outermost layer above 100 kilometers. Next, expansion hypothesis. It is believed that the original diameter of Earth was less than half of its present size and surface area was less than a quarter. Thus, worldwide expansion breaks the Earth's crust into blocks. These blocks tend to rotate sinistrally in the southern hemisphere and dexterally in the northern hemisphere because of shearing forces created between polar and equatorial regions due to adjustment of angular momentum. Now, there are some questions which remained unanswered in expansion hypothesis. Firstly, has expansion actually occurred? And secondly, has ocean water remained constant in volume? Oscillation and undation theory. Formation of geotumors, which are separated by geodepressions, is caused by flow of subcrustal sialic matter from depressions to the tumors. Movement of geotumors under cosmic influence resulted in oscillation of emergence and submergence. Sediments in depressions were filled and consequently glided down the slopes of new tumors. Folded and structurally accumulated rocks were lifted up, and in the third phase they became mountain chains. Objection to this theory is that the basis of cosmic influence is not known, and also the gliding tectonics is not able to explain structural features of all mountains on the earth. Now, let us come to theory of continental drift. Alfred Lothar Wegener in 1912 propounded theory of continental drift. Wegener named supercontinent as Pangaea, meaning all lands, and oceanic part as Panthalassa, meaning all oceans. Now, here in this diagram you can see this single land mass, that is Pangaea. This is Pangaea, and surrounding blue, this is Panthalassa, meaning it is all ocean part. And after that, Pangaea got fragmented into many smaller continents. Here in the second figure you can see the fragmentation, and then they drifted across to acquire the present day disposition of continents. Here in the last figure you can see the present day disposition of the continents. This theory was based on the evidences from geological data, continuity of older structures, stratigraphic formations, fossil fauna and flora across the present continental shorelines. The present day southern continents were centered on the pole and northern continents around equator. Wegener brought into notice of the world that the presence of widespread glaciations in Permo-Carboniferous times around 225 million years ago had affected most of the southern continents, while the northern continents had experienced tropical conditions. Wegener considered the centripetal force exerted by the Earth's movement as the reason for drifting of continents. This was the weakness of Wegener theory, that it could not satisfactorily answer the most fundamental question, like what kind of force could be strong enough to move such large masses of solid rock over such great distances. Now let us look at the evidences of continental drift. Geometrical reconstruction. Continents fit together like jigsaw, which shows that the continent may have been once united together but later on fragmented and drifted apart. Geological evidences. Geologically, the coastline of the land mass on both sides of Atlantic Ocean are found to be identical in terms of lithology and stratigraphy, fossil content, geological structures and style of tectonic deformation. Further, we will continue with the continental drift. Paleoclimatic evidences. The paleoclimate data supports the idea of mobility of continents. The evidences of glaciation of Carboniferous times are found equally on southern part of America and southern part of Africa. Paleontological evidences. Fossils of land plants like Glossopteris and Gangmopteris are found in rocks of 225 million years ago, which is widespread in places over Africa, Australia and India, which are now distance apart, suggests that these continents are part of Gondwana land. Sea floor spreading. These studies have confirmed that continents were once united as super continent, that was Pangaea, which later on got fragmented and drifted. Paleomagnetic evidences. The underwater range of mountains, which are known as mid-oceanic ridge, has been active in geological past and still it is. It pours out lava under the sea. It comprises basalt rock rich in iron and magnesium minerals. In this, crystallization of magnetic minerals like magnetite is affected by magnetic forces. Hypothesis of sea floor spreading. This was proposed by Harry Hess in 1960. It proposes that in sea floor spreading, basaltic magma, it rises from the mantle to create new ocean at mid-oceanic ridges. On each side of this ridge, sea floor moves from ridge towards the deep sea trenches, where it is subducted and recycled back into mantle. Here you can see in this figure, the magma is coming along this divergent boundary, that is along mid-oceanic ridges, and then it is moving away from the ridge towards the deep sea trench and subducting and is getting recycled back to the mantle. A test of hypothesis of sea floor spreading was provided by studies of Earth's magnetism. The data was generated from JOIDIS, that is Joint Oceanographic Institution Deep Earth Sampling Project in 1969, DSDP, that is Deep Sea Drilling Project, and International Phase of Ocean Drilling, that is IPOD project in 1976. These projects, they provided testing ground for sea floor spreading. There are many evidences which tell about the sea floor spreading. The youngest rocks are observed along mid-oceanic ridge, while older rocks occur in the marginal part of the ocean towards the continent. The active volcanic islands are associated with the crest of mid-Atlantic ridge. The frequent occurrence of earthquakes and lack of sediments at the ridge crests explains sea floor spreading. Direct observations, drilling and dredging have provided evidences for sea floor spreading. No material more than 180 million years ago in age have ever been recorded from deep ocean floor. Lastly, the paleomagnetic survey and magnetic anomalies recorded in the rocks of ocean floor provide an evidence for sea floor spreading. Now, after discussing this, what was the driving mechanism for sea floor spreading? Arthur Holmes proposed that the chief driving mechanism for sea floor spreading to be convection currents. Convection currents are generated within the interior of the earth. At the places where two convection currents are moving in opposite direction, the ocean floor above expands and new MOR lava, that is mid-oceanic ridge lava, will emerge and spread over the ocean floor. However, this idea could not get acceptance because heat produced by radioactive minerals was not enough to cause such motion. However, later the idea of convection current helped useful in development of plate tectonic concept. Now we will discuss about plate tectonics theory in detail. This theory assumes that globe is made up of rigid masses of plates consisting of lithosphere which floats and moves along the convection current over the asthenosphere. There are three types of plate movement: divergent, convergent and strike slip. Let us look at the definition of few terms like lithosphere, asthenosphere and plate. Lithosphere is the segment of earth which consists of earth's crust and a part of upper mantle lying above asthenosphere. Asthenosphere is the layer of earth which starts just below the lithosphere at around 100 kilometers depth and may extend up to 350 kilometers. This zone is in semi-viscous state and is also known as low velocity zone because seismic waves acquire a low velocity in this zone. All the lithospheric plates float and move above the asthenosphere. Plate. How do we define plate? Plate is the segment of lithosphere which moves horizontally above asthenosphere, and a plate comprises of the crust and upper part of mantle. Earth consists of many rigid plates. There are three types of plates: oceanic plate comprising of oceanic crust, continental plate comprising of continental crust, continent oceanic plate comprising partly of continent and partly of oceanic crust. In this figure, you can see the first one, that is oceanic plate. It comprises of oceanic crust that is subducting below the continental crust. In the second figure, you can see continental plate. Continental plate is getting collided with continental crust. And then continent oceanic plate, that is on one side you see oceanic crust that is subducting below the oceanic plate. There are 7 major plates: Eurasian plate, North American plate, South American plate, African plate, Indo-Australian plate, Pacific plate and Antarctic plate. Now let us look at what is the difference between plate boundary and plate margin. Plate boundary, it is the surface trace of the zone of motion between two plates. The two plate margins meet at a common plate boundary. Plate margin is marginal part of that particular plate. Four types of plate margins or plate boundaries have been identified based on their interactions. Divergent type, where two plate moves away from each other. Convergent type, where two plate moves towards each other. Transform fault type, where two plates neither converge nor diverge but slide past each other. And triple junction, it is a place or a zone where three plates meet. Now let us go through the basic principles or basic concepts of plate tectonics. Plates move apart from a divergent boundary and get converged along a convergent boundary. Thus a new crust is generated along the accreting constructive plate margin and which get destroyed in the mantle along the subduction zone. Divergent plate boundary, it represents the zone of divergence between the two plates because at this boundary two plates are pulled apart and the gap which is created between them is filled by continuous upwelling of molten rocks coming from the mantle and new oceanic crust is continuously generated. The divergent boundaries are also known as constructive The divergent boundaries are also known as constructive plate margins because the addition of new crust takes place. The whole phenomena of accretion, it occurs at mid-oceanic ridges. Mid-Atlantic ridge is the present day example of this kind of plate boundary. If you combine all the mid-oceanic ridges present on the globe, together it makes to about 65,000 kilometer length. They are located over such zone where two cycles of convection current from the mantle upwell from asthenosphere and subsequently diverge. Mid-oceanic ridges are characterized by shallow focused earthquakes. Convergent plate margins are margins where two plates converge towards each other. The denser plate moves down or subducts below the lighter plate. On reaching the mantle, the melted portion is no longer part of subducting plate, hence it is consumed or destroyed. Convergent plate boundaries are also known as destructive or consuming plate boundaries. Subduction, it is a downward motion of one lithospheric plate under the other. This phenomena occurs at subduction zone or Benioff zone. These zones are characterized by deep focus earthquakes. Subduction zones are marked by oceanic trenches. Oceanic trenches, they are linear depressions formed at the junction of two plates. The trenches are deepest part of the ocean. The subducted or consumed crust along the subduction zone melts. Subsequently, due to buoyancy, the molten rock pours out as oceanic volcanoes. These volcanoes generally form part of an arc known as island arc. The island arc are generally found in parallelism with oceanic trenches. The interior of the earth is responsible for generation of convection currents. The convection currents circulating in the mantle are formed at the boundary of mantle and outer core where the temperature is very high. Conservative margin, at these margins the two plates neither converge or get destroyed, nor they are diverged or generated, but only they slide or shear past each other along a transform fault. The term transformed is used for those large strike-slip faults that displace the mid-oceanic ridges. They are those regions along which two plates slide past each other without creation or destruction of oceanic crust. You have learned about various theories of mountain building, and we have learned in detail about the concepts of plate tectonics. Now let us look at let us learn about the evolution of Himalaya. Evolution of Himalaya is the present day example of plate tectonics. Himalayan mountain range resulted when Eurasian and Indian plates they collided head on. Neither was subducted. The collision of India to Asia occurred about 50 million years ago, and it caused Indian and Eurasian plate to crumple up along the collision zone. After the collision, the slow continuous convergence of these two plates over millions of years pushed the Himalayas and the Tibetan plateau to the present heights. So learners, let us summarize what we have discussed. We discussed about the concepts and theories of mountain building process, theories and evidences of continental drift, forces responsible for continental drifting, and hypotheses and evidences of sea floor spreading. We also discussed about convection current as the driving force for sea floor spreading. The basic principles of plate tectonics were also discussed. We also defined lithospheric plate, asthenospheric plate, and plate margin, and also plate boundary. We also learned about the causes of plate motion and convection current theory. And lastly, we discussed the evolution of Himalaya as the present day example of plate tectonics. Thank you.